Okay, I invited some representatives from Loma Linda and Andrews to come and speak to me in class. I'm going to open the doors to make it easier for them to find us, maybe. But I'm going to go ahead and start rather than, just waiting around. So today, you notice that there was no peruse all assignment, no reading assignment. That's because we're not covering any new material. It's just reviewing for the exam. So we're going to start by doing a little quiz, just some review questions of things that you'll need to know for the exam. So go ahead and log in to the Woo Clap. And right now we have 5. And I was remiss. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We are missing Oksana. Okay. Up to 9. Should have 4 more. 10, 3 more. Who's still working on getting connected? Well, since this is for review, people who aren't connected, I'm just going to move on. So I have the questions separately. The chapters that we're covering on the exam are chapters 1, 2, and 3. Chapter 1 was on an introduction to physics and scientific method. Chapter 2, quantities and units. And chapter 3, no, that's all chapter 1. Whoops, should go on here. Chapter 1 is introduction to nature and physics. Chapter 2 is kinematics. 3 is two-dimensional. So chapter 1, these are the topics from chapter 1 we need to be worried about. Scientific method, quantities and units. Make sure you know what the base units are and you know the prefixes, right? So you should know and pay special attention to the 3 that are M's. Okay, get to the pen. Pen. It actually sets, it sets pen. This, this, and this, which I believe will be here when I come back. No, they're not. Okay, then I go back to pin again. Yeah, see the pin, you guys saw that the pin was highlighted before. Now it's suddenly not highlighted. But it did right because it's a Microsoft issue. So these 3 are distinctly different. What does lowercase m mean? Okay, it does mean meters and units, but as a prefix. Okay, it's milli, which is 10 to the minus 3. What does the Greek mu mean? Micro, which is 10 to the minus 6. And what does a capital M mean? Mega, which is 10 to the 6. Right, so make sure you know those, and you should know from 10 to the minus 12 to 10 to the plus 12 what the prefixes mean. The only one that you need to worry about that's not 3 for the, minus 12, minus 9, minus 6, minus 3 is centi, which is minus 2. That's probably, yes, here they are.
Hello.
Okay, so come on in and give your little spiel.
Wonderful. Thank you for inviting us. Hello, everyone. This is physics class. Yay! Yeah.
Wow, it looks,
physics.
yeah, it looks like only the teacher is excited.
So my name's Yvonne. I'm from Loma Linda, and this is
Hi, I'm Mary Guy, and I'm from Andrews University. I am the enrollment coordinator for the College of Health and Human Services. Were you guys betting or something?
Huh?
No, you look very happy.
No.
I'm glad. Someone's happy to see me.
good.
So we're here to talk about our programs. As you can see, we've set up a table. I saw a lot of you pass by and pick up things and just look at us like, what are these people doing here? Yes, we're here to talk about our programs and tell you that there is more school that you can do beyond this. And you thought it wasn't possible.
Yeah.
No, there is.
So excited for
Yes.
school.
Yeah. So we're here to talk about that, and that is why this evening at 5:00 we have free pizza for you. At the it was a line amphitheater upstairs. We're gonna make a little presentation about the programs, go in details, try to keep it fun and exciting, as we always do. And
If you have any questions about any of the programs we're doing, a lot of our programs are like stepping stones to get into School of Medicine if you're interested in that. A lot of programs we share with Union as well, like our nursing programs. You have as well as I, and so do you guys here at this school. And then there's some programs that we probably will offer that you might not be able to get here. So I have like a rad tech department, so you can do all sorts of radiation sciences with us. We have at least, I think 15 different programs you can get into, nuclear medicine and all sorts of different things for Red Tech, as well as we have the PA program, which is the #1 happiest profession in America right now. So if you're interested in PA, it's a little competitive, but it is a good program to get into. We also have PT that we share. We do communication sciences disorders, the speech path program, and
And we also have architecture and interior design when you're studying physics. So you can study architecture with this as a pre-rec. So that's like Andrews. So
if we spark some interest, please swing by our tables. You can see our brochures and see what we offer. And then come at 5:00 for some dinner. Can we get a hand count of anybody interested in coming tonight? We just want to make sure we get enough pizza. Anyone interested? No?
wow.
We have a physics test tomorrow? Oh, that's why. You're working
Come on now.
hard.
That's why I'm reviewing.
How are you gonna give them a physics test and we have dinner for them?
Well,
They
yeah,
need steady
let it
grades.
sink in, you guys, okay? If you get freed up or need a break from studying, then please come on by,
Make sure
okay?
you take a break. Take a break to come and find out about more schooling.
All right, you guys have a great day.
All right, happy.
Thank you for letting us swing by.
We'll see you around. Thank you.
So allied health professions is something that's largely overlooked. We have a lot of students who come in looking at pre-med or pre-dent, and they don't realize that there are a lot of fields that are associated with those that they could also look into. And so allied health professions has a lot of health professions that work with physicians but are not physicians. And so there's a lot of different options. They just mentioned a few that physics is relevant to. But for many of you, you might be looking at something else, something like medical statistics or medical records management. I know we had a student here, it's been more than a decade now, who wanted to go to Loma Linda Medical School. She got in, and then when she was there, she said, this whole records thing is actually a lot more my style than being a physician. She changed that, and she makes super big bucks. Well over twice what we make as teachers here, which, everybody makes. Actually, I think she started at 3 times my wage, and it's probably higher by now, because teachers don't get paid that much, honestly. Okay, so last thing on chapter 1 that I want to make sure I highlight before we go through the review questions I have for it on WooClap is make sure you understand significant figures and how we use them. So here's our first question, and you can answer now. I actually have the WooClap screen separate, so you don't see the WooClap, you just see this. But I see it.
Is it open?
Yes, it's open.
Yeah, I got it.
Did you have a question, Max?
No.
Okay. Okay, all 11 people who joined up have answered. And so we had 100% said seconds are the base unit for time. Good start. Second question, what is the base unit for distance?
Is it parsec? What's a parsec? Is that an
I'll talk about it after this slide. Okay, everyone's answered, and we have 10 said meters and 1 said kilometer. For distance, the meter is the standard. Hot tip, we use the MKS system. That stands for meters, kilograms, seconds. So it doesn't take someone with a super large amount of knowledge to be able to say, oh, that's the one that M stands for, except for mile is there as a distractor. Now, there was a question about what is a parsec, especially important to people who are into Star Wars. Parsec is an abbreviation for parallax arc second.
Is that a real thing?
It's a real thing, yeah.
Okay.
So angles are measured in, measurements of angles in degrees and radians. While degrees are broken up into minutes, 60 minutes in degree, and minutes are broken up into seconds, 60 seconds in a minute. And so an arc second is 1/3600th of a degree. Parallax is a measurement of the apparent motion of something based on your change. Well, as the Earth goes from one side of the sun to the other side of the sun, the position of something compared to a very distant object will appear to move. Just like if I stand here, I see David between Judith and Jenna. But if I move over here, I see David on the other side of Jenna, not between them. David didn't move, right? I moved, and there's a certain angle we made. That's the parallax angle. And so a parsec is the distance away something is if it has a half parallax angle of 1 arc second. Turns out to be 3.26 light years.
Okay.
So it's a unit of distance, not of time. But people like Star Wars movie creators didn't know what a parsec was, and they just assumed it was time because it had seconds, not realizing that second means 60th of a minute. And minutes don't have to be time, seconds don't have to be time. Okay, so that was unrelated, but curious, interesting fact. So then our next question, what is the SI base unit? Oh, I never answered. The correct answer here then was meters. What is the SI base unit for mass? Claudia is all over this. What was that? No. Okay, we have, well, one more person didn't answer. We had 9 here and 1 here. And it is kilograms. Remember, the K stands for kilogram. And it seems odd because you would think it's gram, because gram is the one without the prefix. But the base unit for mass is the kilogram, not gram.
Is there no system with it, isn't there?
The CGS, yes. CGS system is centimeters, grams, and seconds. But the SI system is MKS. All right. How many significant figures are in this crazy number I made up? Okay, we once again only had 10 out of 13 answer, but all 10 answered correctly. 10. What are the rules for identifying what's significant and what's not significant? What's the first simple rule?
Oh, positively.
Okay, all numbers that are not zero, all non-zeros are significant. Russell? It has to be a trailing zero after a decimal. A leading zero after decimal is not necessarily significant. But a trailing zero after decimal is. And then the other rule, zeros between significant digits are also significant. So in this case, these two zeros were significant because they're between significant digits. And as Russell said, this one here is significant because it's a trailing zero after the decimal. Okay?
Okay, if it
Yeah, go ahead.
ended like the before the decimal, that last zero, then would it be significant?
Okay, so if it was 1, 2, 3, 4, 0. Okay, if it's 1, 2, 3, 4, 0, this is with no more information, it's not clear. It could be that this zero is significant or it's not significant. We don't have enough information.
So then
So
say it's not.
as a general rule, we will err on the side of saying any digit that could be significant is significant, just so we, are making a decision. Way it could be shown that this digit is significant would be to put a period after it. That would mean it's significant. Or if you put a bar over it, that always means it's significant. Or you could just be told, assume it's significant. So if it's just like this, it could be 4 or 5. And I actually have a question that's relevant to that coming up. So do you understand?
Yeah.
Okay. Oh, and it could have been infinite as well. If it was 1, 2, 3, 4, 0.
So
Okay.
any of those answers are correct?
No. If it was this,
Oh, okay.
then it could have been infinite 4 or 5. Okay, so now the question du jour, or not du jour, but the question at hand, how many significant figures are in the sum of these two numbers? So I've written out what it is, you don't need a calculator, but how many of those digits are significant? We have 2 answers so far. Okay, up to 4. Okay, I opened it up again because we only had 8. We're getting down to just over half of the class responding. Nine, 10, 11. All but 2 of you responded. Yay, and those 2 haven't been with us all day, so I'm going to move on. We had 6 people, or 3 people said 6, and 2 people said 7, and
Yeah, I would choose one. Yeah.
okay, I will open it up again, even though it's going to.
But it won't let us change it if you just open it again.
It won't?
It's fine.
Yeah, because we're not doing this for competition. We're doing it for, woohoo, we got a 12th person. Although it says only 11 participants, but 12 have answered, so let's let somebody just re-answer. Okay, and that. Okay, so this is what we have now. It says 11 participants, 12 answers. I don't care. We have a lot of variation here. So this is one we definitely need to review before the test, right? I mean, that's kind of the reason for going over these, to make sure that we're ready for the test. So if you are adding numbers, you have to calculate what the least significant digit is for each number. That is the digit that is the smallest one of significance in each number. So the way I do this is I just write the numbers one on top of each other. 539.35 and 601. And then I'm just going to change the pin color and put a box around the last digit, the smallest digit that's significant. So that's the one furthest to the right. So what in the first number, the top number, which digit is the smallest of the significant digits? That one, or 10 to the minus 2, right? Because that's the column it's in. In the next number, which one is the smallest significant digit? And so that's 10 to the 0. And then you say, okay, which is greater of those? So I just draw a dashed line here. And so my answer is going to be cut off there. And it's you round. You don't just truncate. If it's 1140.9, you don't say, oh, it's 1140. You'd say it's rounds to 1141.
So if it were 1141, would it have 4 sig figs?
This has 4 sig figs. It's good to.
The zeros is
It's good up to this line, yes. So if I would put a period there if I'm writing it out just to signify, yes, that 0 was significant.
cool.
So the correct answer here was 4. You can see there was a good reason why I went over. There is a second correct answer, though.
Is it infinite?
Not infinite, but the 601 could be infinite.
That's why I'm like so confused.
And so if the 601 is infinite, then the greater of your least significant digits would move out to here.
Okay.
And so then you would have 2, 4, 6. So then the other answer that would have been correct the way this was written was 6. And so on the test, of course, I wouldn't give you an, actually, I take that back. On the test, it is ambiguous. And it says answer all of them that are correct.
Answer all.
Yeah.
Okay.
So you have to identify all the ones that could be correct.
Would you mind briefly explaining infinite numbers again?
You mean infinite significant digits?
Yes.
Yeah, if a number is exact, then it has infinite number of significant digits. So if I were to say, how many students are in the class today? The answer is 13.
Okay.
That has an infinite number of significant digits. It's not, well, it could be 13.2, right? It's exactly
Like
13.
we definitely have that.
Yeah, and so that's what gives you infinite significant digits.
Okay. So then things like constants that are calculated that have like a specific number of digits.
Okay, this one here is kind of interesting, especially with the reconfiguration of things this summer. So with the reconfiguration of things, a number of our constants are now exact. So some things that have always been exact, well, always means as long as I've been a teacher, or as long as you've been alive, which is a smaller number of years than as long as I've been a teacher, which is very sad. 1 inch is equal to 2.54 centimeters. That's an exact number. That's how they define the inch today. It's based on that. And likewise, 1 Celsius degree, not 1 degree Celsius, is equal to 9/5 Fahrenheit degree. That is a change of 1 degree Celsius is exactly equal to 9/5 of a change in 1 degree Fahrenheit.
Okay.
Right, so those are exact, and the speed of light, since I've been a teacher, has been c is equal to 299792458 meters per second. As of this summer, Planck's constant is now a constant that is exact. So they've redefined units basically to make that a constant. The definition of an ampere is based on pi. Well, it is exact, but pi is an irrational number. It doesn't end. So that's infinite digits because it never ends. It actually has infinite digits. So there are some others. I'm sorry, I'm spending a lot of time answering with more curiosity questions than beneficial questions on the test. Russell. Well, because it's exactly 9/5. I mean, yeah, you could put 1.8, but 1.8 leaves it open to, is that 1.82 or 1.81, whereas this one here is more clear that it's exact. Okay, one more significant digit question. How many significant figures are in the quotient, and once again, I did the math for you, of 539.65 divided by 600? Answer all that could be correct. So this one is a multiple answer one. And just in case you're wondering, yes, this is stuff that's on the test. I mean, not these exact questions, but these concepts. We have one answer. 6 have answered. Okay. 10 have answered. 11 have answered. There's one message, but I am not going to press that button because we all know I'll get lost. All right, 12, which is all that we've ever had answer today. So we have 6 people said 1, 2 people said 2, 7 people said 3, 1 person said 4, 8 people said 5, 1 person said 6, 1 person said 7, 1 person said 9, and 4 people said infinity. Once again, you can see significant figures is something that you will need to review for the exam because clearly we don't have a consensus. We do have a majority, a simple majority on 3 and 5. This one here, okay. How many significant digits do you have in 539.35? 5. How many significant digits do you have in 600? 1 or 2 or 3 or infinity. Because the first 0 could be significant and the second not. It's ambiguous. Not all of them are right. So what's the rule for multiplication?
The smallest significant digits is what they're rounded.
Okay, the smallest number. So 1 could be the smallest, 2 could be the smallest, 3 could be the smallest, or 5. So the possible correct answers here would have been 1, 2, 3, 5. Not 4 because we don't have any number that has 4 significant digits in it. There's no option to have 4 significant digits in either of those.
So on the test, if we have that exact same question,
Uh-huh.
so it's 4 answers.
If I have this exact same question, yes, there'd be 4 answers. Well, what I have is either answer all that are correct or which one is incorrect. I forgot which way I have it on the test. But I have a significant digits question that's like this. That's crazy. Why are significant digits important? So we can actually judge what we know and what we don't know when we look at numbers. You can see a study and the city will say, 76% of participants had this result. But then you read and you see that they had 2 people, 2 people, you aren't going to get statistics, but a small number of people and their uncertainty is like plus or minus 20%. The idea of the significant digits is so you can keep account of how much we actually know. Yeah, it still does matter, but the engineers err on the side of showing all the numbers. And then they're all like, well, we know somewhat less than what I pretend to know. Okay, going on to chapter 2. Chapter 2 is where we came to the kinematic equations, and we had to know the difference in a vector, and we've only worked in 2-dimensional vectors. I've been looking at Randy's homework, and you're doing everything in 3 dimensions, right?
Yeah.
Aren't you loving that? The difficulty of 3 dimensions, 2 dimensions is not really different, it's just more work. If you can do 2, you can do 3. So, if you have questions about this, I can help you out. So you need to be able to break a vector into components, to combine components to find the magnitude and direction. You need to then be able to use the kinematic equations. You do not have to have the kinematic equations memorized. They'll be given to you. But you have to be able to decide, this is the one I should use, and this is how I'm going to use it. So, get to some more questions. Sorry, I've got to advance this. For a 2-dimensional coordinate system, what spatial relationship must the x and y directions have? Please, everybody answer right. If you listen to Max, Max is out to get you. All right, 11 people have answered, and all 11 said they must be perpendicular to each other, and that's correct, which is how we know Max is out to get you, because he answered correctly, but he told you incorrectly. We used to call those kind of people throats, short for cutthroats when I was in college. There were stories about like people in medical school, they're in the front row, the teacher hands out like 200 handouts for the class, and they take 199 and pass one on to the next person, because then the other people can't prepare. Yeah, that actually is against Union College's academic integrity policy. Huh? I imagine it must be by now.
Yeah.
Okay. Yeah. The theory of that is if I can make everyone score worse, I do better. But that's a bad theory. The goal is for everyone to do well. Okay, moving on. Steps to solving problems. You're not going to have the steps, but you're going to have problems to solve. So this is the kind of thing that you need to have in your head. How do I solve a problem? And there's lots of different ways to formulate these ideas. But first and foremost, draw an appropriate sketch. Once again, I point it to Randy. In case people are wondering, my son is in the same classes as Randy, except for this class.
Oh.
And so that's why I see all Randy's homework. And so Randy has to spend an incredible amount of time in each homework assignment drawing a very careful figure, because he's an engineering student. In physics, we have to draw pictures, but they don't have to be as careful as your engineering drawing, right? Why do we draw a figure, a sketch, in physics problems? To better visualize it, to better get our minds organized. This is what I'm doing. This is how I'm going to get there. So on the last 3 questions, the synthesis question, if you want partial credit, 2 points out of your 10 points are for having an appropriate sketch. It'll be grade 0, 1, or 2. 0, no sketch or an irrelevant sketch. 1, a partially correct or partially useful sketch. And 2 points if it's a sketch that helps to lay it out for you. Yeah.
The sketch has to have the defined point direction.
Yes, if you're using 2 dimensions, even if you're using 1, you should specify what your directions are. If you're going to use like, x equals this, then you should have what direction x is.
No, probably.
Well, it's not like you get 1 for having that, it's you'll lose 1 if you don't have it.
That's what
Russell? No. Good try, though. Okay, so the reason for drawing the sketch is to help you in solving it. It's not just to give you busy work and make it take longer. Right? Because some people, my son being one of them, are like, it's such a waste of my time, but it's for a useful purpose. Number 2, examine the situation, determine which physical properties or principles are involved. At this point, this is real easy. What physical principle is going to be involved in virtually every problem? Kinetic equations. And then there might be an additional one. You might be in 2 dimensions, so you have to break things into components. Right, so right now, that's pretty much all you've got. Not a lot of stuff that you have to remember. For next semester, for the next test, the material we've already started introducing, well, now we have forces and we have a whole new set of stuff. Number 3, make a list of what's known, what's given, and what can be inferred. Right, so we almost never tell you that when I throw here, Randy, throw it back, the twine or paper, whatever, string. Right, so when he throws this in the air, we didn't specify that the acceleration on this object was 9.80 meters per second squared pointing down. You need to be able to infer that. Now, on your equation sheet, it will say G is equal to 9.80 meters per second squared down, but, that's on the equation sheet. You need to be able to recognize, yes, that's going on here. And then identify what you're looking for. And 9 times out of 10, when I mess up on a problem, that's where I fail. I didn't identify what I was looking for. Sometimes I didn't look at all the variables they gave me. because I read a problem and I'm like, oh, I totally know where this problem is going. And I don't read the whole thing. So make sure you read the whole problem and you identify what you know and what you're looking for. Because I have spent 20 minutes finding something to then I look back at the problem and it was given in the problem and not what I was supposed to find. Then you need to find the equation or set of equations that you can use with your concept. Right now, those are just kinematic equations. How do you identify which kinematic equation to use? By your variables. If you don't have time and you don't care about time, see if you can do it with the equation that doesn't have time. If you don't have position and you don't care about position, see if you can do it with the equation without position. Sometimes that won't work for you, but 9 times out of 10 it will. So that's how you make that kind of decision. You can always solve a problem in a longer way, but you're looking for the fastest, easiest way. Now, if you solve a problem in a longer way, I would not take off for that, okay? I don't want people to think like, oh no, I got the right answer, but what if I did it in a different way than you want?
So there's no long way to do things, just the way it happens.
As long as your work is correct. Incorrect work is wrong. And sometimes people will do that. They'll make like 2 or 3 wild errors that randomly bring them back to the right answer for no good reason. Yeah. I actually saw a good meme I'm going to share with you, and it's political, and I could get chastised for this. If you give, a million monkeys a million years, they might be able to, write our Constitution. But if you give one monkey an hour, he might be able to pound out our president's next speech. I know it's harsh, but it's funny because his tweets is basically what I'm thinking about with this. They seem to be randomly drawn sometimes. Okay, unrelated. Moving on. Once you've identified your equations with your knowns and your unknowns, then it's just math. The physics is now ended. Now it's a math problem. So you do the math, and then when you're done, check the answer to make sure it makes sense, has the right units, that kind of thing. If it asks, how long after you throw the ball will the ball hit the ground and you have -3 seconds, that doesn't make sense. Also, if you have 2 hours, but I can't keep the ball in the air 2 hours. Make sure the answers make sense. So now we turn to, actually before I do any practice problems, because of course I'm just going to do problems for the last 12 minutes of class here. Where do I have, Chapter 3, 3-dimensional problems, actually 2-dimensional problems, all the same ideas as Chapter 2, just expanding to 2 dimensions. So there's not a big difference there. Make sure you can do vector addition. You are going to, in one of your last 3 problems, remember you're going to have 4 and you can skip 1. You can't skip the one that requires you to show vector addition graphically. So you're going to have to do a graphical vector addition, which is draw the first one starting at the origin, and at the tip of the first one, draw the second one. Make sure you have an accurate scale. I'm actually going to have a graph that has the scale for you on it. So follow the scale that's on the graph. And then when you're done, you measure the angle and you measure the magnitude to get your answer. So that's another thing that is going to be on the test. And before I work problems, let's see, what do I have here? Yeah, I just have another problem. How do you prepare is another important thing I think I've mentioned, but now is the time when people will really pay attention. I have the worksheets for chapters 1 and 2. There's one worksheet, and for chapter 3, there's a second worksheet. I look at those to help guide me in choosing what I should be putting on the exam. So if you can do everything on those worksheets, you're probably in pretty good shape. For the problems on the worksheets, where can you find solutions on the worksheet problems? Okay, one answer is YouTube. If you go to YouTube, on the tutorial videos, which are linked on the Moodle page, you can hear me going through how to solve it, explaining. You can see the part where I was like, I'm calculating this wrong, I'm double checking my number, and there's where I had my mistake in my calculation. right, you hear me doing the solution, explaining what I'm doing as I go through. Because oftentimes you see somebody doing it, you're like, why did they do that? Well, that just leaves a hole in your knowledge. So that's one option. What's the other option? Where?
What's your question?
Where's the other option for seeing the solutions? If you go to OneNote, now I don't do the answers for the knowledge questions. I call them here conceptual. I should call them knowledge. But I do the problem solutions. This is actually where I did my solution that is on YouTube. And so you have all my work for my solution here. You don't have the words here, though, because I spoke and I wrote. So this is where you can just see the solution, but you don't have any explanation. Question?
So when we're supposed to like give our explanation for stuff on the test, do you want us to just say for concept, you just want us to say like kinematic equations or?
At this point, yes. At this point, that'll work. Later on, you'll have to be a little more involved.
Okay, because I was like, I don't really know about that. And what about the ones that are like velocity is like what it is, and then like speed? I was like, how are you supposed to explain how you know that? It's just like.
Well, that wouldn't be a synthesis question where you're doing that. That would just be multiple choice where you don't have to explain.
Oh, you don't have to explain those.
Yeah, it's only the synthesis ones. Yeah, only the synthesis ones. Okay, so now let's go and just look at problems. So once again, this is on OneNote. Everybody has access to OneNote. You should have all received an email from it. And even if you can't find that email, you should be able to go to Moodle. And in Moodle, there is, see if I can log in correctly. Chances are not good. Hey, I'm already logged in, it says. Great. Just take me to Moodle. Don't tell me I'm logged in, take me there. Did you guys see that Rick Ocasek died? Y'all heartbroken? Guess you're not. The lead singer for the Cars. Okay, let's just not even talk. Drive.
Name another favorite song they have.
Heartbeat City.
Are you talking about like Pixar's Cars?
No, I'm talking. Anyway, right here is the link for OneNote materials. I changed the link from the original one, so now it no longer takes you to OneNote on your desktop. It always takes you to the web version of OneNote. But then when you're in the web version of OneNote, you can click a button to open your desktop version of OneNote. So that's where you can get to the OneNote materials, which I will point out is also a place that's useful for homework solutions. Because when a student comes for help with homework, I usually do the work here on OneNote, and I leave it there so other people can see the work we did. They don't hear the discussion, but they see the work. Okay, so Claudia, what's up?
I would have to talk to Evan to get into the Microsoft. I don't think any of us can get in. I don't think I'll be able to get in either.
It's using the same account information that you use to get the free Microsoft Office software. It's not your Union College account. It's the one you made with Microsoft using your Union College email account.
I didn't do that.
You didn't get the free Microsoft Office? So, yeah, I don't know the ins and outs because I did that like 7 years ago or something like that. And I have a password thing that just remembers my passwords everywhere half the time. Okay, so let's go to today's lecture. This is also where you find the lecture slides and see how much of a problem we can do in our remaining 5 minutes. So here's a one-dimensional kinematics problem. Actually, let's just go to the two-dimensional kinematics problem because you can do the two-dimensional one, you can do the one-dimensional one. So we have a situation now. Remember, I told you, you're not going to have a question on the test where the ball starts and ends at the same height. That way people can't use the special case range equation. They actually have to do the work. So we have a problem that says, how far will the ball travel for a given initial speed v? Assume no air, which means no air resistance. Also means our golfers got to have a self-contained breathing apparatus, not a scuba. When I was in the fire department, somebody said I got to put on my scuba, and the instructor was like, we're not underwater, and that's what the U in scuba stands for. Yes?
Isn't that the range problem?
Yes, remember I told you on the test, you won't have the same starting and ending height, so you won't be able to use that range equation.
So this one is the same starting and ending?
This one is, yes.
Is there an example of one without it?
Right.
Well, sure. I've played plenty of holes where the green is like 20 feet higher than the tee box. Sure. It doesn't matter to me. So I'm just going to do that. I'm just going to say that you end at y final is equal to, let's say, 3.5 meters, and y initial equals 0. I need to define my x and y directions. Remember, it doesn't get you a point. It takes away one if you don't. So I'm going to define horizontal as x, vertical as y. What's the angle between those two? 90 degrees. Okay, everyone got that on the quiz. Identify my knowns and unknowns. Come on. Take my pen away and it works. So my knowns I have x initial equals 0, y initial equals 0. X final equals, I don't know. Y final is equal to 3.5 meters. Because I just specified that because we wanted to see an example where it wasn't 0. Vx initial equals, that's for a given speed. We have v, right? So I need to break my v into its components, and that's going to be assumed to be a known because I'm finding it for a given speed. So I take my v vector, and it has in the picture that's 54 degrees above horizontal. Breaking into components, one direction that's parallel to y, one that's parallel to x. Remember, you have to have x component plus y component is equal to the resultant, the vector I'm breaking up. So based on my xy coordinate system there, this is the x component, this is the y component. Identifying opposite, adjacent, and hypotenuse. I have, this is the opposite side because it's opposite to the 54 degrees. This is the adjacent side. Identify that sine theta is opposite over hypotenuse, which is then Vy, the opposite side, over the hypotenuse of V. Therefore, Vy, and that should have been Vy initial and Vx initial. So Vy initial is equal to V initial sine of theta. I'm just leaving it at that, especially because I only have 1 minute left. Cosine theta is equal to adjacent over hypotenuse. So once again, looking at my triangle, that's going to be Vx initial over V initial. Solve that for Vx initial. So I have Vx initial and Vy initial there. So I just put my Ax equals, was my acceleration in the horizontal direction? 0, right? That's why I chose vertical and horizontal. So one direction would be 0. What about acceleration in the y direction? Negative g, or negative 9.80 meters per second squared. Excuse me? When it's in free fall. That's correct. When it's in free fall. So now I need to decide, how do I use these kinematic equations? There's our physics. So far we've had problems set up, which isn't really physics. It's important for physics. But the real physics is thinking about how this works. And I'm like, well, the vertical motion will determine how long it's in the air. And then if I take how long it's in the air and multiply it by the horizontal speed, I'll get the range. And so I don't have time to do it, but my solution is to use the vertical component use vertical data to find the time. Now I'm going to find time as a function of v because it said find your answer in terms of v. And then plug t into horizontal data to find x final. So there's my method, and then the rest is math. Right there, my physics is there in the red and the blue, and then it becomes a math problem. Not necessarily an easy math problem, but we've gotten through the hurdle, the hard part. Yeah.
So a lot of our OneNote accounts are not working. Is there any other way to access the answers to those worksheets?
You can make a OneNote account and access it if it's not working. You can make a new one.
For free?
Yeah.
How do you, like, I mean, I have an account and it signed me in, but it said it wasn't connected to my college one, so then it said it wasn't working.
Okay, I'll have to look into it then.
It wouldn't, like, I was signed in and it specifically told me you can't go any further because it's not connected to your email, so.
I thought they were
I don't
open to
think
everyone.
that
Okay,
it-
I'll look because I thought it should be open to everyone.
Oh, and then,
Go ahead.
is this like as hard as the problem we'll get on this first test?